So we move to yet another one, area of a parallelogram. I have videos I have prepared for grade 8 class on the properties of quadrilaterals, and I think it's important you go back, watch these videos to help you understand, because to deal with the area of any shape, you must have an understanding of the properties of that shape, right? So we expect this to be parallel to this. We expect this to be parallel to this. But what is more, we expect this to be equal to this. And we expect this to be equal to this. So the figure we have on the board is a replica of what we expect a parallelogram to look like. So we can take our perpendicular height. We can take from this point, H. This is base. Remember that for a parallelogram, the opposite sides are equal. So if I establish that this is my base, then this side is also equal. So if I use this side or use this side, I'm as good as correct. The height here will still be the same thing as the height here. And what's the area? The area of a parallelogram will be equal to the base times the height. Please bear in mind that anytime we mention height, we refer to height as the perpendicular height. What is perpendicular height? It means height that is standing vertically. If I keep a pen like this is vertical, very upright. If I keep a pen like this is what? Horizontal. You must take note of these concepts. So we'll have that one. This is B times H, which will be BH. So the area of the parallelogram is what? The base times the height. Alright, so let's see if we can take a problem or two under this idea. So we have on the board what is called the parallelogram. The parallelogram, and we are required to look for the area of this shape. We have the one side given to us as 5 meters. We have this side given to us as 3 meters, and the height is also given to us. So how do we go about solving that? So we'll find out. Okay, this is the parallelogram as we'll be given. Now let's see how we can solve that. The first thing we need to identify is what is the base. The base is this part. You have to be careful. If this is the base, then this will be the right height to consider. If you call this as the base, this cannot be the height. Look at this. The base means where are you staying? The height means how are you standing? So let's try to turn this and look at it, whether what I have said is right. Look at it. Are you seeing it? So you see this is why you can't use this as the base and this height. The base and the height are related perpendicularly. The those we say by talk by A is said. So you see that there's a base and there's a height. Alright? So this is B what? 5. And the height being what? 2. Are we together?
Yes, sir.
Are we together? 2 meters. So what is the area? The area of palm. I want to begin to teach you shorthand. Parallelogram is written as what? Palm. And that palm is spelled as P-A-R-M for short. So start getting used to it. I'm going to teach you early enough before you come into grade 10 how to manage abbreviations. That's something we don't teach so much again in schools. And it's a challenge. You need to learn that there's an abbreviation. So area of palm. It's not the palm that your mind is talking about. And that is 5 times 2. Yes. Or we can go back to say that this is what? B times H, which is BH. Just writing that for emphasis sake. And this will now give me what? 5 times 2, which will be 10 meter squared. Is that clear? Is that clear? So with that said, area of palm is what? 10 meter squared. So that's just more like what you need to take note of. Remember what I talked about? In answering this question, this is what you should focus on. Remember, base, height. However you draw it, if you take now, let's go with that our format again. If I want this to be my base, see the height will come like this. I see it. So if I'm using this as the base, the height must come like this. Are you seeing it? Are we seeing it? So that's what will happen. Get the concept. Once you get the concept, solving problems become very easy. And by the help of God, we also take our time to make videos that will focus on problem solving. Focus on problem solving. But essentially what I want to try to achieve is to help you see how these things are done. So take our time to practice them, and I'm sure you'll be able to handle the questions in your book. So we consider the area of a rhombus, and a rhombus is a square. It's a special type of square. No, sorry about that. I think I made a mistake there. A square is a special type of rhombus. That's the right thing. I want to implore you to watch my video on plane shapes. You're really going to enjoy it, because let me just add this. A rectangle is a special type of parallelogram. A rhombus is a special type of parallelogram. So, see, you need to know all of these, because sometimes in your JS3 exam, they set things like this to test whether you understand the concepts. So let's come back to the area of a rhombus. We imagine that because I had said that a rhombus is a special type of parallelogram, we should expect certain basic features of the parallelogram showing up here in the rhombus. With that said, something rather interesting we notice, all the sides are equal. All the sides are what? Equal. All the sides are equal. Now, added to that, another interesting feature you're going to see in a rhombus is that the diagonals bisect themselves at 90 degrees. The diagonals bisect themselves at what? 90 degrees. So what makes a rhombus very special? Number one, we said that a rhombus is a special type of parallelogram, which means that we expect all the features of the parallelogram to be present in it. But added to that, we expect all the sides to be equal, and that when the diagonals intersect, they intersect at what? 90 degrees. It is this very important feature that we're going to use to obtain our formula now. So, now, please watch this. I didn't tilt it enough, so you may not really appreciate what I've done. So this part is called the height. And because we said that all the sides are equal, it means all the sides can be correspondingly called a base. I'm using the same letter B for all of them, because all the sides are what? Equal. But watch carefully. This diagonal here, from here to here, let me name the shape A, B, C, and D. A, B, C, and D. Now, the area of a rhombus will be equal to the base times the height. That's one formula. We can also express the area of the rhombus if we know the diagonals of the rhombus. So, there's an added formula to that. We can say that the area of a rhombus where diagonals given, where diagonals are given, will be equal to half AC times what? BD. AC is a diagonal, BD is another diagonal. So half diagonal AC times diagonal BD will give me the area of the rhombus. So you have two ways of calculating the area of the rhombus. And I want to give you an assurance. This one is likely a question you will see. They love setting this one. When we come to properties of, when you look up my video on this, you see other things that are already interested here. You discover also that if you look at this figure very well, you can see 4 right angle triangles. Is that not? 4 right angle triangles. 1 right angle, second, third, and fourth. So another way you can look for the area of the rhombus is to find the area of this, 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 and do what? Add up everything together, and then you obtain the area of the rhombus. So we'll pause on that, and then we'll try to take problems related to the area of the rhombus. Find the area of the rhombus above. So to find the area of the rhombus, we need to look for, what we are given are the diagonals. Is that not? Remember I told you that anytime you have something, so we can call this, let me label it A, B, C, D. So diagonal AC is equal to what? 4 plus 4. And that will be 8. And let's assume the units are in centimeters. We put that initially. We are assuming the units are in centimeters, so this will be 8 centimeters. Then we look at diagonal, what do you call it? Diagonal what now? BD. 3 plus 3. This looks odd. Let's switch them. Although somebody might query me mathematically because pictorially this side looks bigger. Let's correct that. Let's correct that. Pictorially this is what it should be. So this should be 3 plus 3, and that will give me 6. And 4 plus 4, and that will give me 8 here. So what is the area? The area of rhombus will be equal to what? Half times 6 times 8. I remember my counsel to you earlier. Do your calculations. And that will give you 3 times 8, which will give you what? 24 centimeter squared. So that's it. Area of the rhombus using your diagonal method. Half of this diagonal times this diagonal. So that's using your diagonal method. So using the other method will not be a problem for you, because if you just imagine what you have done when we're considering parallelogram, it becomes easy for you to handle this problem. Okay, by way of reminding ourselves, we can also consider the area of a rectangle and also consider the area of a square. Now, we know that a rectangle is a parallelogram. A rectangle is a special type of parallelogram where we have all the angles as being 90 degrees each. So this is 90 degrees, this is 90 degrees, this is 90 degrees, this is 90 degrees. And this side is equal to this side, and this side is equal to this side. So if this is length, this will be what? Breadth. So what would the area be? The area of a rectangle, will be equal to length times breadth, which will be LB. So this is quite okay, and you can see that that's quite straightforward and simple. We'll go to the area of square. These are things you've done previously, so I wouldn't spend so much time on them. Now for the area of a square, we know that for a square, all sides are what? Equal. And another interesting attribute of a square is that all the angles are also equal. Now, a square is a special type of rectangle. A square is a special type of rhombus. Keep those two things. You need to lock them in your imagination. Right. So let's draw that quickly. Alright. So the area of a square will be given by, remember that because we said all sides are equal, we expect all sides to have the same length. So the area of a square, will be equal to length times length, which is the length squared. Recalling your knowledge of what again? Indices. Recalling your knowledge of what? Indices. Okay, so that's for area of rectangle and then area of square. Let's see if we can close out with the area of a trapezium. Now for a trapezium, we imagine something of this nature. A trapezium has one pair of what? Parallel sides. Has a pair of what? Parallel sides. Now, the parallel sides are given names A and B. A and what? B. And then we have the perpendicular height called H. So how do we look for the area of the trapezium? Very simple. Area of a trapezium is giving us half of summing the parallel sides. So in looking for the area of a trapezium, you must identify first of all, where are the parallel sides? So A and B are parallel sides, so you must find half of it first. And whatever I get, I'm going to multiply with the height. So that will give you half into A plus B height. So that's the formula for calculating the area of a trapezium. Okay, we'll take an example and then we'll see how that applies to real life. What is the height in this diagram? If you look at it carefully, there's 7, there's 3, and there's 6. I forgot to indicate the parallel sides. In any diagram of this nature, you must identify the parallel sides. Once you have identified the parallel sides, the next thing you want to do is to try to identify the height. This is not the height. We said that the height is a perpendicular distance. So, what I didn't put the height in here. So, how do I know that this is the height? Because of this sign, 90-degree sign. So, it means that A is equal to 3, B is equal to 6 cm, and H is equal to 5 cm, based on the diagram I have on the board. So, the thing I want you to remember here is this. Sometimes they can give you a question like this in the exam, and you'll be saying, but there's no height, there's height. This one that is 90 degrees to this side, it's already an indication that this is the height. So, area of trapezium will now be equal to half into 6 plus 3 times 5, which will now be 6 plus 3 is what? You must treat the bracket first. Half times 9 times what? 5, which will give you 45 over 2. And if you do your maths correctly, this will give equal 22.5 centimeter squared. Remember, we have said area is always in centimeters squared, meters squared, and the likes. Okay, we're going to pause here today as we close out on our study of some of the plane shapes. We'll continue in our next class by looking at more plane shapes like circle and more on composite shapes, shapes that we have plane shapes brought together. We want to see how we handle such questions. So for now, it is MAMU with Jarvis signing out for today, and trust you will go back to do your work. Thank you very much, and see you.